Hello everyone, I am Chalma Reddy. Welcome to CR Maths class. Previous class we are completed up to 44 problems. Now, see small concept here, characteristic equation of a matrix. This is important in engineering also. How to apply the characteristic equation of a matrix, when we need to apply, and what is the definition of that. See, characteristic equation of a matrix. If A is a matrix, order n by n. N by n means it is square matrix. If A is a square matrix, then det A minus lambda I is equal to 0 is called characteristic equation of the matrix A. If A is a square matrix, then det A minus lambda I is equal to 0 is called characteristic equation of the matrix. So here A, take 3 by 3 matrix, then its characteristic equation det A minus lambda I is equal to 0. Okay, now here see one example. If A is equal to 1, 1, 0, 1, 2, 1, 2, 1, 0, then find A cube minus 3A square minus A. Generally, how to solve this problem? First find A square, next A cube, substitute here and identity matrix also. Add all these three, then you will get the answer. There is a lengthy method. Okay. If characteristic equation methods is very easy. Characteristic equation of A is A det of A minus lambda I is equal to 0. How to write that is A minus lambda into I. I means identity matrix. What is A matrix first? 1, 1, 0, 1, 2, 1, 2, 1, 0 minus lambda into I. Identity matrix means you know very well 1, 0, 0, 0, 1, 0, 0, 0. Multiply with lambda, you will get like this lambda 0, 0, 0, lambda 0, 0, 0, lambda. Now, these two matrices subtract what we get 1 minus lambda 1 0 1 2 minus lambda 1. Next 2 1 0 minus lambda. This is A minus lambda I. Then apply the determinant. Here already applied determinant. You know the symbols. Here is the plus, here is the minus, here is the plus. 1 minus lambda into, multiply these two, minus lambda into 2 minus lambda. Next, this way, 1 into 1 minus. Minus 1 into minus lambda, 2 into 1, 2, that is minus 2. Next term, third term should be 0, no need to take. Now calculate here. Finally, we are getting in terms of lambda, lambda cube minus 3 lambda square minus I is equal to 0. In place of lambda, replace A is square matrix. Then we get matrix equation A cube minus 3A square minus I is equal to 0. So in this method, we get answer very easily. Students, are you understood how we are solving the question? In IP, you are solving like this. First, you are finding A square, next A cube, and identity matrix. Both are subtracting or adding, whatever maybe. Then you will get the answer. 0 means null matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0, like that. By using characteristic equation, we get answer very easily. This is important even though in engineering also. Okay. A matrix given. Now here we need to find first A inverse, then A minus AI into A minus CI. A minus AI into A minus CI. Then how to do this? Tell me how to do this. So here, first we need to find A inverse. For suppose A matrix A, B, C, D. Then how to find A inverse? 2 by 2 matrix, no? How to find A inverse? This is the formula. 1 by AD minus BC into D minus B minus C A. This is the formula. But here, what they are given A matrix A, B, 0, C. Then how to find A inverse? A inverse is equal to 1 by AC minus 0 into C minus B 0 A. This is A inverse. Now here observe that A minus AI into A minus CI is there. So that means here we need to find a characteristic equation. So what is characteristic equation formula? A minus lambda I, that is equal to 0. That first of all, what is A minus lambda I? We need to find A minus lambda I matrix. A matrix A, B, 0, C minus lambda I means lambda 0, 0, lambda. Now subtract these two, we get A minus lambda B 0, C minus lambda. Now determinant of A minus lambda I, that is equal to 0. Apply the determinant here. What we get? A minus lambda into C minus lambda. C minus lambda minus 0. 0 into B 0 or not? That is equal to 0. Okay. This is I am writing lambda minus A into lambda minus I, that is equal to 0. In place of lambda, here this is not I, this is C, this is C. Now in place of lambda substitute A. So these equation I am going to convert into matrix equation form. A minus small a into identity matrix into A minus C into identity matrix, that is equal to 0. This value we got 0. This is 0. But A inverse already we know that. Finally, A inverse plus A minus AI into A minus CI, that is equal to, what is A inverse? 1 by AC into C minus B 0A plus this value should be 0. Now finally the answer is 1 by AC into C minus B 0A. This is the answer. Students, observe that which option correct? Which option correct? Third option correct or not? Third option correct. Now 46th question. A alpha cos alpha minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1. But see the options. First two options, see here. Statements, 4 statements. Out of 4 statements, how many are correct? How many are correct? So A alpha into A beta, A alpha into A beta. So first and second both are same, but right hand side value is different. Now I am going to write A alpha into A beta. A alpha means already given that is cos alpha minus sin alpha 0, sin alpha cos alpha 0, 0, 0, 1. This is A alpha. A beta means just in place of alpha, replace beta. Cos beta minus sin beta 0. Next, sin beta cos beta 0, 0, 0, 1. Now multiply these two matrices. Then what happens? See. So first row, first column, we get cos alpha cos beta. One second. Here I am writing. See, cos alpha cos beta minus sin alpha sin beta plus 0. This is first row, first column. First row, second column, cos alpha minus sin beta. That means minus cos alpha sin beta. Next, minus sin alpha cos beta. And first row, third column. So 0, 0, 1. So finally you'll get 1. Now I am going to write second row, first column. What we get? Sin alpha cos beta plus cos alpha sin beta. Next, second row, second column, minus sin alpha sin beta plus cos alpha cos beta. Next, second row, third column, this is completely 0. So first one also 0, no? This is also 0 only. See carefully. Now, third row, first column, 0, 0, 0, completely 0. Third row, second column, 0. Third row, third column, 1 will come. Next, students here observe cos alpha cos beta minus sin alpha sin beta. That is cos of alpha plus beta or not? Cos A plus B formula. In second term, take minus common. Cos alpha sin beta plus sin alpha cos beta. That is sin of alpha plus beta. Next 0. Same like that second row also, we get sin alpha plus beta. Here cos alpha plus beta. Cos alpha plus beta. Next 0. 0, 0, 1. This is. So these answer. Observe here. Same statement. In place of alpha, what is there? Alpha plus beta. So this is, we can write A alpha plus beta. A alpha plus beta. Which option correct? First option correct. Students, are you understood? Fourth option. Fourth option. So first find a data of A alpha. There you will get answer. This is data of A alpha. That value should be 1. Then cofactors of A alpha. Symbols, you know that. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Then apply that, delete the row and column. AD minus BC. You'll get cofactors of A. Adjoint A is equal to cofactors of A whole transpose. Then apply the formula. So you will get like this. But this is not A alpha. This is cofactors of A alpha. Adjoint A means we got like this: cos alpha, sin alpha, minus sin alpha, cos alpha, and 1, 0, 0. But those type of matrix not there. That's why in place of alpha, I am replaced minus alpha. Cos of minus alpha, cos alpha, sin of minus alpha, minus sin alpha. So finally, A alpha whole inverse is equal to, we got A of minus alpha. Okay, so this statement is correct and this is also correct. Overall, fourth option correct. Okay, students, remember it formula directly, you can remember. Read the question carefully, what they are given, observe here. The product of the matrix B with A matrix has inverse C. That means BA is equal to C inverse. There is a condition. And B matrix given, C matrix given. We need to find A inverse. But here there is no A inverse. Then how to find? See, multiplying on both sides with B inverse. B inverse BA, that is equal to B inverse C inverse. So matrix multiplication is associative. So B inverse B into A, that is equal to B inverse C inverse. B inverse B, how much? Identity matrix. Then I into A, that is equal to A1. So finally here we get A, that is equal to B inverse C inverse. But we need A inverse. Apply inverse on both sides. A inverse is equal to B inverse C inverse whole inverse. What is AB whole inverse formula? Generally, that is B inverse A inverse. This is a formula now. So apply here. C inverse whole inverse, B inverse whole inverse. C inverse whole inverse means what? C or not? So here we get C. This is B. This is B. Then how we get A inverse means product of C and B. Okay, students. Now C matrix. What is the C matrix? C? Minus 1, 0, 1, 1, 1, 3, 2, 0, 2 into B matrix. B matrix 2, 6, 4, 1, 0, 1, minus 1, 1, minus 1. Now do the product, you will get the answer. How to do the product you know very well. First row, first column. What will come? Minus 2, 0, minus 1. First row, second column. Minus 6, 0, plus 1. First row, third column. Minus 4, 0, minus 1. Now observe here. How much this value? Minus 3. This is minus 5. Minus 5. Minus 3, minus 5, minus 5. It is there in two options. Okay. So need to multiply some more elements. See here. 092, 092, 214, 214. What is the difference? 6 and 16. That means multiply third row, third column. Third row, third column. You get answer. So I am not multiplying these two. See, third row, third column. 2 4s are 8. 0 into 1, 0. 2 into minus 1, minus 2. Students, how much we are getting? This is minus 3, minus 5, minus 5. These elements I am not multiplied. Multiply yourself. This value is 6. So by observing that, which option is correct? Third option correct. That's why whenever you are multiplying, observe the options. Which element is need to multiply? Okay, then only the time will be saved. Yes or no? Right. I think all of you understood now.